Welcome everyone. My name is Samuel Kamochu, and I'm happy to have you guys today. My objective is pretty simple: to help those guys who have some of these concepts, server, services, pods, and Linux, as new terminologies to them or sometimes confusing. I just want to ensure that I make your life much easier. So the objective of the day is to appreciate servers. I know some of you already do appreciate servers, don't worry. OS, processes and services, and use of ports. We keep mentioning, the web server runs on port 80. What are these ports? And then we'll be able to access a server. I know some of you indicated that they have never accessed a server. And we'll also learn a few things, basic Linux commands. So I'll go very straight into a repo that I've created, and I have a diagram that I have put up together to help you guys appreciate these things. So we'll come and revisit this diagram because the server that we have given you that you're going to access is actually a virtual machine. So they are real machines, physical machines, and they are virtual machines. So by the end of the session, all these things will make sense when you hear the ports, when you hear the processes, when you hear daemons, when you hear OS kernel, all those things are supposed to make sense. And we are going to practice some of the things together. So I hope that you can join me in this journey, a short journey. And I'll move very quickly, inspired by one Peter Mutisia, to just ensure that we go through what I've put together. So I'll start with part one. And I want to just repeat some of the things that some of you might be very familiar. So here I'm talking about the hardware and the software elements of a server. So one of the things you need to know is that a server has CPUs. This is straightforward. If you do not know that a server has CPU, you can go to our YouTube channel, Natujenge, and look for how a computer works. So I have in detail explained how the computer works, the purpose of the bus, memory, and all those things. So it also has memory. That's why when you're buying your laptop, it has some memory. It also has storage. So you talk about SSD or hard disk. All those things, they are within the storage space. And it has other I/O devices. And specifically because our servers are in the cloud in day-to-day operations. So we will talk about network interfaces because they come in very handy. Because the servers are very far, somewhere in Europe. And we just need to ensure that we connect these things via, we just need to ensure that we connect to these servers through a network. So network interfaces can come in handy, and a server can have multiple cards. So if you have ever studied, RJ45, if you did that in school, those network interface cards where you can put the cables, a computer can, or a server can have multiple of them. And the network interface can be physical, like the ones you have on your laptop, or logical, when you have certain interfaces that are logical within your system. E.g., when you talk about 127.0.01, so we know that that's a logical interface, and it's called the loopback or the local interface, where if you send traffic to 127.0.0.1, or sometimes referred to as localhost, the packets do not leave the computer. But if you send them through maybe at 0 or any other interface that you have on your computer, then you can see that you have that. One of the things you'll notice that if you have a card is assigned an IP address and can be used to connect to a certain network. Another card can be used to connect to another network. So in a typical server setup, if you go and set up physical servers, because personally I've been part of that, there is a requirement within enterprises that a server must have at least 2 cards for redundancy. And you connect them to 2 routers for redundancy, meaning every server has 2 IPs for the sake of redundancy. So that is something very common. It has a keyboard and a monitor. Now, you already know that a server runs an operating system. It could be Linux, it could be Mac OS, or it could be Windows 10 or whatever operating system that you have. So the work of the OS is to manage these things, the resources we talked about. We have the file, memory, process, and I/O management. When you're dealing with these, you're basically ensuring that the jobs or the tasks that need to be done utilize the resources, the hardware resources that have been assigned to that server accordingly. So if you want to write to the network and another guy wants to write to the network, the person who deals with that coordination is actually the OS. And at the heart of the OS is something called the kernel or kernel, whatever you want to call it. But it's basically the thing that is at the heart of the OS, and then the other things are added on top of it. So a server can run multiple processes. And I know I might not have described what a process is, but any application that is running, like even this client, this browser, anything that is running on your computer is a process. And the process basically processes some instructions. And it processes using those instructions using the CPU. So every process sometimes requires access to the CPU for it to execute the instructions that have been written by the programmers. So processes can either run in the background or foreground. So when you say foreground, it means that if you're on that interface, so you can interact with a process that is on foreground. Like some of you might have written the first application that captured input from a standard input where you say enter your salary and then you key in using the keyboard. That process was running in the foreground. And the moment that interface dies, the process also dies. But you also have processes that run in the background. So they don't have an active interactive user session that is attached to it. And I've used the word terminal here. Don't worry. We'll explain what a terminal is before the end of this session. So when you run foreground, it's what you can interact with, either command line or a GUI. Background is what is running at the back end. So if you wake up and start a Zoom application, it's running on the foreground on your laptop. If you open a browser, it's running on the foreground and you can interact with it. But if you have some processes that are running on the background, you probably don't have an active interactive session or an active thing that you are sending commands to that thing. And those processes are very critical in our lesson today. So a process has an ID. It's identified by an ID. So please remember you have processes that run on the computers or on the servers, and those processes are managed by the operating system. That's why you can see one of the key things for those guys who did OS in school. You know that process management is one of the key functions of the operating system. Now, what's a daemon or a service? A daemon is a process that has the following properties. And sometimes we call it a service. So it runs in the background. So it has no direct interaction with the user. It is often started during boot up, or at times when you start the application, it runs continuously even after you have left the interactive session that you used to start. And then the other thing is it's also often used for events that may happen at any time. So e.g., if you have a web server that needs to respond to incoming requests at midnight, then probably you need a daemon that runs on the background. So if you could think of the web server service that runs that allows us to access the web at any one point, it's a daemon. You could think of other processes that to run for our bases. You could run them as daemons, and we call them services. Their work is to serve requests. That's why they're also called services. Now, services can be accessed remotely in case you need to access that service remotely. Like you can deploy your website on a server, put it there, let the web server to run continuously as a daemon, and then we use port 80 as the door to get into that service. So if a service requires remote access, then we use ports to identify which service you're connecting to. And I know I don't want to get into the finer details of what ports are, but if you go when you're in about the OSI model, server has an IP address, and if you want to communicate at transport layer, then you have the port, source port and destination port. So when you're sending requests to a server, you send the request to the same server, but the same server could be running the web server and a mail server. So how do you tell the OS which process you're sending the data to? And that's why we use the port. So you'll say, yes, it's going to this server, but port 80, then the OS knows, okay, this is meant for this service that runs on port 80, which is called the web server. And if you want to send an email, then you send data to the server, but then you tell the server, use port 25. And of course, at port 25, there is a service that is running the SMTP or Simple Mail Transfer Protocol service or SMTP service. So that's how ports are used. So you have ports for file transfer protocol. If you want to push files to the server, you still need to access a service that runs on the server, and you send the file to it. It is going to write it to the disk. So those are services. Secure Shell, I'll not talk about it more here, and Telnet, SMTP. And as a matter of fact, some of you will be creating embedded APIs, embedded web apps or applications that have a web server inside them. You're going to expose a port. And some of you who run even front-end development, sometimes when you're doing those, you're doing development on your machines, you always see localhost and a port number that is provided. It's because you are talking to a service that is able to handle your request through the ports. Only that, sometimes it could be you're talking through an interface that is localhost, but the ports are used for identifying which service are you communicating to. So a port can be any number that is a 16-bit number. For those of you who were with me in the previous sessions where we are learning about the basics of how computers work, digital communication, you know that a 16-bit number can have a possible permutation of 65,354 values, starting with 0 to the maximum being 65,353. So you can use any number. You cannot use 70,000 as a port number because it won't work. Now, these ports 0 to 1023, they are reserved for common applications. Like, web server runs on 80. We do not expect you to run another service on port 80. They are called well-known ports. So if you use 22, we expect you have secure shell service running. If you have a port 23, we expect it's the telnet service. If it's 25, we expect you're running SMTP service there. But it doesn't mean that if you run SMTP service on port 80, it is not going to work. It will work, only that you'll be confusing the rest of the world because they assume 80 runs the web server. So this is something that you need to know. So when you're creating your applications that require a port to be exposed, you know how to choose. Some services don't require ports, and I'm at this point here. And at this particular point, if a service doesn't require a port, then you don't need to expose a port. So you can have a process that runs as a daemon that has a process ID because it's a process, but it doesn't expose a port because it does not need anyone to access it remotely. E.g., the firewall service that comes with most of the Linux installation or operating systems, it doesn't require a port, but it runs as a daemon to ensure that you can protect people from accessing your service illegally. So you can whitelist IPs and block IPs at the firewall layer. So again, it's a daemon, it's a process that is running. Anything that runs on the computer must be a process. Now, it is possible for one service to expose two ports. Also remember that. It's like the port is the door to a service inside your server, and that door allows the external world to connect to that service remotely. So if your server has an IP address and your service has a port, then we can actually talk to that service from anywhere as long as that node is accessible from where we are. So that's one thing that you need to know. So if you have a service that has two doors, you can actually have two ports that are pointing to the same service that are receiving requests of different nature. Here we have the web server, which most of the times exposes two ports. Port 80, which is HTTP, it's insecure, there is no encryption, and port 443, which has encryption in place. So when you see HTTPS and you find that this thing has HTTPS here, it says the connection is secure. It means that there is actually a port here, which it is implicit because it's well-known port, and we know 443 is the well-known port for HTTPS. So if you put it like that, it will still work. So if I refresh this page by putting the port, it will still work. So sometimes the port is rejected, 443. Yeah, it's basically rejecting the port, but just know that we are using 443. So definitely if you come here and you put a port that is not correct and we do that, it won't work. So you can see my browser is struggling to get the page, and eventually at some point it will time out. But because I don't want it to time out, allow me just to do this. Now, a service serves requests. So remember, a service is still a process. It's also called a daemon that runs in the background, sometimes exposes a port because you need to access it remotely at any one point. And some people, because of the natural wording that a service is serving request, sometimes we call it a server. And it's not to be confused with a physical server, which we talked of, that has, the CPU and all that. And we also have another server, which could be the software solution that receives request through a specific port. And sometimes we call it a server because it opened the port as the door for placing requests from external. So up to that point, I want to take a small pause and ask whether there is anyone with a question. Sorry, Steve, are these the most commonly used ports? Actually, if you Google well-known ports, Steve, yeah, they're not most commonly used ports. I just chose a few for the sake of argument, but you can go and look at all the ports that are registered for the various purposes. So you can see here we have even SNMP. There are many protocols, DHCP, if you are getting the dynamic IP addresses, DNS for resolving, sciencedirect.com into an IP. So there are many things that are used, but I think this article, if I'm not wrong, I had shared it. But the common ports are based on what you use. Like port 22 is very common because if you're going to access the server, then you're going to use SSH. So it becomes very common. If you're a MySQL guy, then port 33 or 6 is the gospel truth that you must never forget. So it all depends on what application that you're running. So there is not, I don't think there is a commonly used port, maybe commonly used services that come with common ports. I've just listed a few to help you know that in the OS you can run many services. Okay, so let me now move on to another part, and I would like you guys to also comment in case you have a query. A shell is a Linux program. I know some of you might have heard about a shell and a terminal. So I want to demystify this for you. Some of you already interact with shells, but maybe you've never understood what it is. It's a program, so it's code written by some people like you that takes in commands from the keyboard, or the keyboard actually, and gives them to the operating system, the kernel, to perform a certain task. This is basically a command line interface, and it is the alternative to a GUI. Now, one thing that I'll tell you is that most of the servers you access don't have a GUI, or at least the servers that you deploy your services on don't have GUIs. So you can't get in there and you click a button. If you want to install something, you need to know how to install it via command line. And that's why those Linux commands come in handy. There are different types of shells. Like on Linux, we can have the Unix shell or the Bourne shell, which is accessed using SH. There is Bash, there is C shell, Conch shell, Z shell. All these shells allow you to write commands. Like if you want to delete a file, there is a command to delete a file. You write it on a shell. And then, of course, as we mentioned earlier, the shell passes the command to the OS. The OS passes the command, or basically executes the file management command, like delete a file, onto the resources that you have. Maybe move some files on from the disk, and many more things that you can do on a physical server. So why shell? Because servers don't come with GUIs, unlike our PCs and our Macs that we use. It's also an important thing for you to understand that as an engineer, you cannot ignore shell. Ask any engineer who is an active engineer within a telecommunication or software engineering space or any other space that you want. They are developers and they are running services in an enterprise. They will not run away from shell. So if you want to know whether you're using the bash, you can echo this mostly on the Linux and Mac OS, and you will deal with that. Now, what's a terminal? So the shell is the program that takes in command and passes to the kernel. But the terminal is the GUI application that we normally open to ensure that we run those commands. So the terminal is the tool that we use on my desktop. Like when I open here and I said that on most of our applications, you'll find that there is terminal. So let me come here and just look terminal, and I have this. So this is a terminal. Now this terminal allows me to send commands to the shell. So if I write a command here and I do ls, it basically sends the command ls to the shell, and the shell sends to the OS, and the OS does whatever it's supposed to do, the kernel that is, and basically gives me the list of the files that I have there. So I'm listing whatever is in that directory. So I hope that's clear. So for some of you who do not have a shell or a terminal on your laptop, so I'll give you guys this so that you can ensure that you download if you're on Windows. Yes. So Peter, I will answer that question of, and Martin, I'll answer the question of NIC card, and so Peter, I'll respond to your questions once we do this. And so allow me just to share this. So if you don't have a terminal on your laptop, you can actually get PuTTY. It's a simple one. You download it and then you click it, and it will ask you to specify the server IP, the port, and the username and the password, and you can use it to access the server. So if you want to access a server, you can access local access. You go to the data center and look for the keyboard on that server. Normally, servers are not like our laptops. They're on racks. So you go there and you log in to the server manually using the monitor that is provided on that server. So most servers will come with a tool to allow you to just access the server. So you can log in locally, but most of the time we use remote, and this requires a special program. So you can access server using telnet command. It's not secure. You'll not hear it a lot most of the time, but it's a very useful command for other things, not for accessing or logging in into the server. It used to be popular at some point. And we also have secure shell, which is another program that allows us to access a server. And this is the one that we use mostly. So you hear people saying, can you SSH to the server? They're basically asking you to log into the server, which is remote. So it's a very common thing that you learn, and you need to know how to log in into the server. And by the end of the session, I'll ensure that I show you that. So you may need a client program like PuTTY that I've said. I've already shared the URL for PuTTY, and some of you could download. And there are many, many terminal applications that you can run. So you can Google for popular terminal on Windows or whatever that you can run. Now, to log into the server, and I will give you guys the command to log into the server. Then we first end here and answer a few questions, and now do the trial to log in. So a server comes with an IP address if that server is to be accessed via network. And you also need a username and a password to be created. And if you do not have a username and a password, there is another way of logging into the server using a username and a private key. I know some of you will probably study encryption, public key infrastructure, and you've heard about the public key and the private key. This is now the private key stuff in play. Of course, this lesson, our focus is not to help you understand how private keys and encryption works, the asymmetric encryption works on the internet. Our idea is to let you know that you can actually log in using a username and a password, suitable when you're logging in on an interactive session. Or you can use a username and a pair, suitable when you're writing an application that can log into another application. You know, sometimes you could have a thing that wakes up at 10 a.m. Or maybe 4 a.m. in the morning, logs in into another server, checks a few things, and then does 1, 2, 3. So you can write a script or a process or a software to do a job every night that involves checking other servers. So maybe that script might require to do SSH to another server. And at that particular point, the key becomes in handy. So if you have your own CI, CD, those deployments, keys come in very handy because there is no one to type in their password. But with the key, you just give a key for that server and allow it to access through that. So the key idea is SSH, username, and IP address, and it will ask you for the password. So up to that point, I will ask for anyone who has a question to pose as far as logging into the server, the shell, the terminal is concerned. And if possible, ask anything about the servers, the ports, and the fact that we talked about the processes and daemons. So I will answer Martin Kagendo's question where you're saying, do the two network interface cards increase the speed? No. Two network interfaces allow you to have redundancy and have maybe other complex networking needs that you may have within your organization. The network interface cards do not increase the speed. And maybe I don't know what you meant, the speed of what? But the network interfaces card, they are basically meant to help you some networking needs, the redundancy, as we said, on the server. Or maybe you also need to have logical separation of certain processes within your application. And what do I mean by that? When you hear Docker containers running, for those of you who have gone and studied Docker networking, you'll hear that each and every container is given an IP address, and there are those logical interfaces that will be created even on the host, maybe on the host machine. When you do the port mapping, there are some things there. If I go and run the command that is used to check the interfaces on a computer, like I come here and say if config, you'll find that I have a lot of interfaces that have been provided here. Some of them are not real because I have maybe the Wi-Fi card. Actually, this laptop has only one card, the Wi-Fi card. It doesn't have any, but you can see the look back. So they're just helping you to help your service be seen from a very different perspective or from different networks with different IPs for whatever reason that you want to achieve. Yeah, so when I was telling you about the terminal, this is my terminal here. So how did I open it? I went to, okay, I can basically get it. Let me just close the terminal, then I open it afresh. So I can go to, okay, I can do to my launch. On your machine, you'll have a terminal on your own. If you do not download one, you can download Putty as an example. So if I do clear, this is a command to clear my screen. Those are commands. If I do ls, this is a command to do ls to list a directory, and it shows me all the folders and the files within the current directory. And if I do pwd, that's another command that prints my current working directory. So the key idea that I wanted to say here was, I can use history to see what I was running. Oh yeah, I ran the command ifconfig on Linux or Unix. I think in Windows you say ipconfig, one word, and you can see all the interfaces that I have. These do not increase the speed, but they allow some of the applications to achieve maybe some networking isolation. But don't worry about them for now, Mr. Martin. So Peter, you're asking, can you define your own port and what happens when you share ports? So Peter, I don't know what you mean by defining your own port, but essentially what I had written here in this presentation, I can tell you that you can actually create your own application here that I've called it a web app that has an embedded web server. And you run it and you give it a port 17,671. It's still within the range of 0 to 65,000. So it will still work. Now, the question is, yes, so you can define a port. You can tell your application to run on a certain port. But now there is a small catch to it. If one application is running on port 80, if you try to run another one that asks for the same port, it won't work because you'll be told that the port that you're asking for is already in use. So for those of you who have done maybe network programming, you know you can listen to a port. So you build your application, SSHD, and you tell it to listen for a request on port 22. If you try to run another instance of the same application and it tries to listen to the port 22, it will be told that the port is already in use and you cannot use it. So Sospita, yes, you can use a port. You can decide to use your port. Even you can change the web server. Instead of using 80, you can change it to 8080. And you cannot share a port. One service on the same host cannot share a port. But if you have two machines, you can have port 80 running something and another machine, port 80 running something. And the same applies to containers. So within the container inside, you can have port 80. So if you have a container that has port 80 inside, another container can have another port 80 inside. But if they're supposed to expose those ports to the host machine, some of you might have experienced this, you cannot map 82 times, otherwise it won't work. So you have to give the first container, maybe you expose on the host machine with port 81, and the other one you expose it to through port 80. So there is a thing on port mapping, but I don't want to talk about port mapping on Docker, but just know that no two processes can use the same port on the same host, on the same machine, on the same OS, as long as there is one OS, or within the same container, if we think about containerization. Yeah. So then the other thing that I could answer, can you define your own port and what happens when you share the port, or how do you avoid collision? There is no secret of avoiding collisions, Hospital. So you just organize. Ports are like resources. You assign them nicely. So because the server is not supposed to run many things. So I know on our application, I have port 7, port 8, port 7070, port 7071, port 7078. You write it on paper and people implement that. If someone tries to implement a different thing, then of course it will fail at the time of binding or the time of listening. So that's what will happen. Now I'll move on to the next part, which is now logging into the server, and I will come here and I'm using Linux. So if you have a terminal, you could try this out. I think one of the things that we said about logging into the server is actually you say SSH. If you're on a terminal, if you're using PuTTY, you might do something differently. Then you have the root user. And we have the IP. For those of you who are asking, what is this IP? Now, this is the time to use the IP. And you put that. If you cannot see, this is an @ sign. You know, you could be seeing something very different. So if you do so, then what you do is, if you enter, it will ask you something, can't establish. Are you sure you want to continue connecting? Don't worry about fingerprints. So just say yes. And if you do so, it will ask you for the password. Awesome. I was able to log in, and I can see that the last failed attempt, I can see the last login there was a guy from this machine that was able to log in. And essentially, you're inside the server now. Please note, you're inside the server. You can see this terminal. There is a command here if you want to know which shell that you're running on. So you can do echo shell. And it will tell you that I am actually running on the bash shell, if you guys remember. So please let me know in case, please comment on chat if you've been able to log in and ensure that one of your group members is able to log in. So I can see quite a number of guys have been able to log in. If this is your first time to log in on a server, please comment on chat. If you've never done SSH before, this is your first time, please indicate this is my first time, and we'll appreciate. I can see William, Calvin. I think majority of the people have logged in. Please do not shy away. Thank you so much. You can do DM in case this is your first time, and yes. Thank you so much. So I think permission denied with the correct password, Kibet. We will troubleshoot with you after this. Yeah. So thank you guys. Now you are inside the server now. Now I want to teach you guys a few commands, and I want to install one software that we are going to install. And I would like you guys to also go there and, do something. So I'll run a few commands. You can actually do PWD. It means print working directory. So it means you're within a folder called root because you're a root user. If you log in with another username, the default folder is actually the user folder. If you do ls, it lists whatever is in the directory, and I can do that, and there is nothing. Now, but also there is something here that I've mentioned, that when you SSH, there is ls. Now, if you do ls, you can add switches. So one of the things that you need to know is that, okay, sorry. I think I overjumped. I went forward, but let me just tell you guys, the server we are using is Linux, and a Linux server has a kernel that is based on Unix. Unix is a thing that was created back in the days by, I think, a company called AT&T. The same AT&T that has telecommunication services in America, but they created something. We have Linux today, and we have a lot of distributions that are based on Linux, like Ubuntu, Red Hat, and we have the community version. Actually, here we are using CentOS Trim, which is community version that mimics Red Hat Enterprise Linux. Why did I use this? Because I know some of you will go and work in enterprises where Red Hat is the only OS that they know. So I want to teach you the commands which will make you fit for working in the market. So if you go work for most of the corporates here, mention any, whether it's KCB, whether it's Safaricom, whether it's Airtel, Telcom, they will probably give you Red Hat Enterprise Linux, and these commands will work. So we have ls, which you have seen. We have this, which you have seen, print working directory. And I want to talk about special directories that you know. But before I do that, I can give you a command called create make directory, and I can say Natujenge. So I don't want you to make a directory inside here, but I have made a directory called Natujenge, and I can do ls, then you'll find there is a directory called Natujenge. But one of the things that I will show you is that you can do ls -l, that shows you even who created it, when it was created. It's a long list. I can also do ls, and I can say a because of something special. Now, when you came here and I did ls -l, you realized there was only one folder, which is a D here, directory. If it doesn't have a D, it's not a folder. My shell allows, or the bash that you're using has certain capability that colors folders differently from files. If you want to know how many folders are here, this is one folder because of the color, and you can see it has a D folder because of the color that has a D, and these are files, but they have dot in front, and you have Natujenge, we have dot and dot. There is something special if you name a file or a folder starting with the dot. And it means that those files are hidden. They always start with a dot. Dot gitignore, dot git. All these things are hidden. So if you do ls by default, you'll never see them. Right? So I hope you guys can try out these commands, and I'll give you a moment to do that. But now I can change directory, and I can get into Natujenge there. And if I do so, if I do print working directory, I was in root, then I change the directory to Natujenge. And once I got into Natujenge, then I'm able to see that I'm inside there. If I do ls -l, I see nothing. If I do ls -la, I see something. There are two folders that are special. Now, anytime you see a folder called dot, if you say cd dot, it means you're changing directory to the current folder. Dot is the same as the current directory. So if you do cd dot, it won't do anything. It will remain, it will leave you in the same folder. Now, if you do cd two dots, then it's the parent folder. So you're basically going back. It's like hitting a back arrow when you're navigating on the front end. So you can see, and you can see something here. Now, there is something special about cd dot. It took us back. So if I come here and I want you guys to try this out, if I do I did NatuJenge. So I did NatuJenge, I made an erroneous error to call it NatuJenge. I didn't put the right spelling. So I'm going to practice another command. If I do cd minus L, these are called switches. If you do ls, it is a full command. Oh, someone has created NatuJenge. So let's say, for example, yeah, I've seen it. Someone else who has created NatuJenge. So if I do cd NatuJenge, my full NatuJenge, and I go inside, and this is where I want you guys to play. I want you to make a directory that has your email address. Like my email address is kamochu@gmail. So you can paste it with your email address, and you can do that. And you can go there and you discover that there is Kamochu. So I want you guys to log in, go to NatuJenge, cd NatuJenge, get inside there, create your own folder with your name. And I'll be able to know how many guys have done so in a few minutes. So I'll give you guys a small break. Calvin, I can see. Alvin, I can see. Ensure that if you know a guy who has done it and you're unable to do it, we will ensure that the other guy is able to help you. So I can see, Musembi, you wrote your full Gmail, which is okay. I mean, even @ is accepted as a folder, and I can see guys inside there. So be happy that you've been able to practice. I want 2 more people. Please, Mfadhili, thanks. Thank you, thank you, thank you. Please, you can continue doing so. So I've demonstrated the less PWD, and I've demonstrated this. Now, one of the things that I will log into Mfadhili, I will not log in. I'll change directory to your folder, and I can do that. And now I'm going to change 2 dots. And of course, it will take me out, 1 folder out. That's what 2 dots mean. Now, I will also log into Steve. I'll change directory to Steve Wakongo. In Linux, you should not have spaces in folders. We do not recommend. Or Steve. Yes. So Steve, I'm inside your folder, and I can confirm by printing the working directory. And what I want to do is I want to go back to my home. So I'll teach you another folder that is very unique. It's called the tilde sign, the one on the keyboard. If you do cd tilde, just like cd dot is special, cd 2 dots is special. Cd dot ensures that you're in the current folder. It doesn't move you because you're changing to the current directory, which does nothing. It's illogical, but it will be used in other places. cd 2 dots, you're basically moving to the parent folder, because remember, folders are hierarchical. It's like a tree. If you do cd dot dot, you're going back 1 step until you go back to the root. If you do cd tilde, tilde is actually the home folder. So if I do this, it means this is the home folder of the user who is logged in. Sometimes in Linux, you ask yourself, who am I? And it tells you your root. So the root folder for root is actually /root. Sounds quite intelligent because they couldn't find another way to be more intelligent. Yes, the root folder for root is root, basically. Now, if you have a folder like this is now the real root of the server. Please don't play commands from here because you'll mess us up. So just ensure that you do that, and then you get into your folder. Consider NatuJenge Maranga, tunakuona hapa what you're doing. You created your own folder outside instead of creating it inside here. Then Calvin, you didn't create a folder, you created a file. But I'm hoping that you are trying out other things. So there are many, many commands you can learn. I want you guys to play those commands. Try not to do any command that is dangerous. But if you do it, please, we'll forgive you. Come back and tell us what you did and the lesson that you have learned. Do not remove. Linux, you're the root user. Like, unlike Windows, where you have, those prompts that tell you, this could be wrong. If I come here and I say remove the whole Natujenge folder, it will remove it. You can even delete the OS files if you want. So you need to be careful when you're using remove, ensure that you're actually in the right folder. Many people have made those mistakes and we have had an issue. Now, one of the things that I'll note is that Collins created his folder here. But because we want Collins folder to move to Natujenge, I can actually say move Collins H and I move it to Natujenge. That way. And once I move, you can come here and confirm that Collins is not there anymore. And I can come here and I go inside and you'll find that the Collins folder has actually gone here. So you can actually move folders, and whatever Calvin has created here, because Calvin created a file, and how do I know it's a file? If I do this, you can see that this is a file. The color tells you. So I'm going to teach you another command that is called remove, and Linux is case sensitive, so you need to have that. And Collins, please avoid using spaces in the file name. I can see you use the space. Please ensure you don't do spaces in Linux. You'd rather do underscore hyphen or just that. Sorry, what did I just do? So if you make a mistake, you can do Control C. Control C cancels what you're doing. So I can delete Calvin's file and I can, yes. You want to remove a regular file and I can say yes. Yeah. So you can see what has happened. So we've been able to do that, and I talked to you guys about how the cat. Let me show you how to create a file for ourselves. So I'll go to my folder. I want you guys to go to your folder, and I hope you guys will obey the instructions. My folder is, if you don't know where you are, you can do pwd, but sometimes the shell gives you an idea of which folder you are in. Now, if I want to change to my folder, Kamochu, I do cd, change directory to Kamochu. If I want to confirm, I can do pwd. Then I can use the command cat, and I can do $, redirect the content, and I say my first.txt. That's my first file. Or maybe I can call it file1.txt. You don't need to give a file an extension. Then it will give you a terminal. On the terminal, it gives you something sort of a prompt. You can enter stuff and you can say this is test content, line 1. Then I can do enter and I can say line 2 and I can enter. And after I am done, I can press Control C to finish. Control C is something that rescues you most of the times. And if I do ls -l to see the long list, I'll see that you have the file 1 and file 2 second. So the guy who created second, tafadhali, go back to your folder. Who are you? Who created second? Please confirm on chat. I want to show you guys how to move. So the guy who created second, Kiptanui, thank you so much. So Kiptanui, what I'm going to do is I'll copy your file, copy command, now there's a new one. 2, I go back one step, then I look for a folder called Kiptanui. Sometimes you can type the full name of Kiptanui's folder, or you can use tab to help you autocomplete. I've just pressed tab after typing KIP. Now, once I do that, I'm copying this file to prompt to. Of course, here, I can say dot. So I'm copying the file in the current folder. This is optional. I don't have to copy it. And what I do is, actually, I don't want to copy. I want to move because it's not supposed to be in my folder, so I can move. And if I move, if I do -L, the long list, I have file 1. If I go, also long list has a special command. If I do long list and I come and do --/Kiptanui, and then I do that, even without changing, I can see second has moved there. So ensure that you practice playing with these commands. But one of the things that I want to show you guys, some commands as I conclude, because time is not on our side, I'm going to show you how to install our software. Now, we are going to install Apache Web Server. And it's not in the document, so this is a bonus. So I'll come and do yum install. You use yum install in Linux, and I can say httpd. So I can do that. So it will ask me that, you found httpd. Now, some of you might be asking, why httpd? Because http, it means it's a web server. D means it's going to run as a daemon. So if you ever see a D at the end, don't get confused. It's basically a service that runs as which is another name for a daemon. So HTTP is not a foreground process. It's a background process. And that's why it has a D, just as a naming convention. You don't have to have a D in the name for it to run at the back. So you can even call your process a cow, and it will run whether in foreground or background, depending on what you as the developer want to do. So sorry, I aborted. I didn't enter. So it is asking me to install, and the answer I'll say is yes. So by doing so, I have installed. So yum is the command we use to install softwares. Remember, sometimes you go download. Here there is no GUI. You have to do installation on this. There are many commands. Yum is the utility that is used for installation. I think I've mentioned it somewhere here. Did I? If I didn't, we'll add it at some point. So in this command, I have so many commands that are there. There are many links to all the commands. Please ensure that you spend your time wisely and you run. Now, one of the things that you'll notice that if I come, because you guys know the IP address of this machine, if I come here and pick that IP, who can tell me, let me just check the IP address of the server. If I come here and I type httpd, then I put that server. I can also add the port because now we know it does not give me anything. So it tells you the site cannot be reached. Now I want to ensure that we install a web server and we put a test web page on that server. So what I'll do is I've already installed, but is the service running? No. Now in Linux, there is something that used to be called service, which is a command that just like ls, but service is the command you use to manage services. So you can do service status name. This is an old way. Most of the time you will find that it told you, okay, we didn't respect what you wrote. We actually used a different script. So this is another way of running the service. But because I'm a lazy guy, ideally you're supposed to use his systemctl command instead of the service command. But I use this because I know most Linux distributions default back to the right command for me, and I find it easier to type this for me. So how do you start the service? So you have httpd, and then you can do start. Now, once you start, how do you check the status? Definitely, you just do status. And you can see it's running now. It's running, and at these particular points, we know that it's running on port 80. If I come here and run this, then it gives us a test page, which is HTTP server test page. This page is used to test the proper operation of your server that has been installed. If you can read this page, this means that your work is working properly. This server is powered by CentOS. If you're a member of the general public, so we are using CentOS Stream, and this is basically a default page that was created there. Now, I know I talked to you guys about the 7 questions of understanding a service that you never created. And I'll come here again, repeat the same questions, and I will use some of the things we've done here to just show you the final bit about running the server. So have the web server, you know what it does. You know how to install, yum install, we know how to start, we know. Location of the configuration files, I'll not take care of that, but the location of the data files, I'll show you where the default folder is for Apache, and the key folders like the default folder and any other things that you need to know. So the key thing here is, by now, we've been able to see how these things work. If you do not you can actually run the history command, which is another command that shows you all the commands that I have run on my side. And I hope that the commands that you run on your side, you can also use history to ensure that you remember. So I can share this so that some of you who are probably not familiar with some of these commands, you can take time and look at them. Now, one of the things that I want to do as I finish, sorry, copying has backfired on me. One of the things that I want to do as I finish, we know that the var, for those of you who are doing Docker images, you know that Apache web server puts folders here. So I'll come here and we will create the first HTTP file, HTTP HTML tutorial. So I just come here, I'm a lazy guy and I just want to copy the first web page here, and we are going to come and we will basically, I'll basically come here and I will put on my notepad here and I'll come and put this and we'll say first page, NatujengeOYF, and then I can come here and I say NatujengeOYF, and this is the first paragraph. So this is basically a HTML file. What I am doing is I'm developing on the server. Ideally, you're not supposed to develop on the server. If you note, the root folder has nothing. That's why the web server defaulted to what. So I've shown you here, you can come. So go and learn how to use cat in your groups, and then I can do Control-C. If I do that, I'll confirm that the index.html file is there. And if I want to know the content of the file, I can also use cat, but now without the redirection operator here. So I'm not going to do this. So I'll come and do that, and you can see the file. If you access this guy now, you'll be able to see that our website has been deployed. So definitely the reason why we are learning containerization is because no one should be doing this in this day and age. You should not even deploy the servers here. So I hope I've given you guys some head start in terms of getting to play with the Linux server. If you've never had a server, I've given you access to a server. Please ensure that you create files, you edit files, try to run Vim. If you get confused, Control-C comes to the rescue. If you do not know what to do, there is another thing that comes to your rescue. Just close the terminal, start it afresh, just in case you get confused and you don't know how to exit. You are editing a file using Vim and you cannot know what to do. So there are many things that you're going to learn with time. But the key thing I wanted to know is that you can actually try these things on the server. So if I come and do echo, then I quote and say test, it just echoes test, it prints test. So there are those commands that you're going to learn. And if you have any questions, please ask. We are more than happy to come and do another session. As I conclude, this is my last slide. The server we've given you is a virtual machine running on, I think, I'm not so sure whether it's Scaleway or it's DigitalOcean. And you can run a server on a virtual machine on other cloud providers. So the key idea is that every VM that you access runs on a physical server, which we call the host server. And ideally, it comes with the CPUs and all that. So the VMs, you can have a server that has 32 CPUs and 192 GB RAM, and you give 4 CPUs combined with X number of GBs of RAM, and together you give them a disk space that is, you just you isolate some of the resources. The guy who does that is the hypervisor. So the work of the hypervisor is to isolate those small resources and say that I want a VM that is 4 CPU, 8 GB RAM. And it will pick from the pool of the resources available on the hardware resources and assign them to your VM. So of course, when you get the VM, it's like a machine which has no OS. You come and install your Linux OS. So here we have the CentOS Trim as our OS. And now we have installed HTTPD, and we have port 80 open because of starting the service. And you have port 443 open because of starting whatever that you have. And essentially what we have is that hypervisor. Now, what we have here on top, this is our VM. So please take note that the hypervisor, there could be 7 VMs sitting on the same hypervisor. So you have one hypervisor, N VMs. Each VM has an OS, and each VM can have its own processes. It would be quite interesting, and probably I'm willing to do another session to see how now containers look like if you bring containers. But the reality of the matter is that it's a bad idea for you to start a VM and run containers on it. It's not a recommended idea. There is a lot of wastage, and you don't need to do that. So if you're running containers, don't talk about VMs. And that's why we have now other things that we can look at. I don't know whether there is anyone with a burning question, but I'll choose to end there. And I hope the session has been helpful to someone. If it has, food for our encouragement is confirming that you have benefited so that we can keep doing the things that we are doing.